Question 1. Question 1A. A1. If sine theta is equal to 3/5 and the terminal side of theta falls in the second quadrant, find the value of cot theta. So we're looking for cot theta. And we are told that the terminal side of theta falls in the second quadrant. So terminal side falls in the second quadrant. So this will be the theta and 90. Now sine is opposite over hypotenuse. So this opposite, that one is 3 and this is 5. So if this is 3 and the other one is 5, how do you find the one that is down? We say 5 squared minus 3 squared, which is 25, minus 9, which is 16. So the square root will be 4, and it must be -4 because it's on the left side of the x-axis. And cot theta is 1/tan theta, whereas tan theta is opposite over adjacent, 3/-4, which is -4/3. So we have found cot theta. It's that easy. 2, if...
Sir,
Hello.
what do they really mean by the adjacent side? The terminal side, I mean.
The terminal, the end. When they say it's terminal sign, they mean side. They mean the end side of it. So always the starting point is on the first quadrant, then it's ending in the second quadrant. So like if it's an angle, we're saying it's starting here and ending somewhere there within the second quadrant. So it's ending there. So theta always lies on the x-axis, so that will be theta. So if you want to form a triangle, we cut like that. So that's the meaning of the terminal side.
Thank you.
Okay, then the other one we have sec theta is equal to -5/3 and cosec theta is less than 0. Find the values of tan theta. Now, if cosec is less than 0.
Mr. Mzengwa, sir. Hello, sir.
Hello?
Can you kindly repeat on the cot part? Like, I didn't hear. Can you kindly repeat on the cot part? Cot theta.
Okay. So cot is 1/tan. And tan from Sokotoa tan is opposite over adjacent. So opposite is the opposite of theta, which is 3. Adjacent is the angle that is is the side that is holding the angle and the 90 degrees. So we get tan theta to be 3/-4. But there's a 1 on top. So when we resolve this, it becomes -4/3. That's what we did there. So there is nothing.
Okay, thank you.
Right. So when sec is negative, cosec also is negative. What quadrant is that? We know that in the first quadrant they are all positive. In the second quadrant, cosec, which is 1 over sine, is positive. In the fourth quadrant, sec, which is 1 over cos, is positive. So it means that we are dealing with the third quadrant. So the terminal side lies in the third quadrant for this one. So this becomes 90. This becomes theta. And sec, remember sec is 1 over cos. So for it to be negative 5 over 3, we have cos theta to be 3 over negative 5. So of course we know that here cos is adjacent over hypotenuse. So of course the adjacent here will be negative 3. Hypotenuse is never negative. So what will be the other side? Again, we'll say 5 squared minus 3 squared, which is 16. So again, we have a 4, and it's a negative 4 because it's this distance from that line there going down. Now, we're looking for what? We're looking for tan theta. Tan theta is opposite over adjacent. So opposite is negative 4. Adjacent is negative 3. So we'll get 4 over 3. And that's the reason why we say tan is positive in the third quadrant. You can see it has come out positive. And that's how we get that. So that was 2. So we go to question 1b. B, prove each of the identities. The first one,
Sir,
hello,
kindly repeat on the previous question.
we have 2 parts.
You'll be hearing previous
So which part should we repeat?
on the same one for sec and cosec, how you determine the terminal. Yes, the terminal points.
So we said here sine, cos, sec, cosec, cot, and tan. They are positives in the first quadrant. In the second quadrant, we only have sine and cosec to be positive. The other 4 are negatives, meaning sec, cos, cot, and tan. These are negatives. These are negatives. In the third quadrant, tan, cot, these 2 are positives. Sine, cosec, cos, sec, these are negatives in this quadrant. And so cos and sec are positives in the fourth quadrant, and tan, cot, sine, and cosec, these are negatives in the fourth quadrant. Now what we are given was cosec is negative. So you go where cosec is negative. It's negative here. It's also negative in the fourth quadrant. But we are told also sec is negative. But sec is positive in this quadrant, in the fourth quadrant. So it can only be this quadrant where they are all negative.
Oh, sir. So for this question, we have to look at both cosec and sec. Where they are negative?
Yes, because sec is what? sec is -5/3.
Okay.
And the cosec is less than 0, meaning it's negative.
Wait. So, sir, what's the importance of this cosec here? Like, since we've been given sec is equal to -5/3 and cosec theta is less than 0, what's the importance of the cosec here on this question?
It's for you to be able to know the quadrant where the quadrant where theta is. Remember in the Tel sheet we had this question where in the Tel sheet we had this question where you were asked to determine which quadrant theta lies if you are given sec negative, cosec negative. So that's the use of the cosec here. Because without this cosec, you don't know where sec is, because you know sec is negative in the second and the third quadrant. So which quadrant are you dealing with? You don't know. So you must be guided by bringing something else. Okay, now we prove the identities. Sec squared theta is equal to cosec theta over cosec theta minus sine theta. Now, whenever you see sine, cosec, sine, sec, sine, tan, you change everything that has to do with any other trig or function to sine and cos. So in this case, we'll pick the right-hand side and express it in the sine and cos relationship. So this is the same as what? Cosec is 1 over sine. Cosec is 1 over sine minus sine. So you can put over 1 here. So this is for the denominator, you get sine theta down, and then you have 1 minus sine squared theta, and then on top we have 1 minus sine theta. If you write this, it will be 1 over sine theta divided by 1 minus sine squared is the same as cos squared theta over sine theta. If you change the division to multiplication, you get that over cos squared theta. So sine and sine cancels. You have that, but you know that 1 over cos is sec. Now because cos is squared, so you're dealing with the sec squared theta, which is your which is your left hand side. Which is the left hand side. Hence, so identities are very easy for as long as you know how to move from another trig ratio to the sine cos. Life becomes very easy. Eh? So we go to the second one.
Sir, can I please see the previous screen? Okay, thank you.
So cos A, 1 minus tan A plus sine A cosec O. So kind of yourselves, I'm also recording for other guys who are not here. So if you If you insist in unmuting yourself, I will mute you out. So we have 1 minus tan A, 1 minus cot A. So we pick the left hand side. And so the first thing here will be you choose to get the common denominator at this point or to change everything to sine and cos. So first, let's change everything to sine and cos. So we have cos A over 1 minus sine A over cos A plus sine A over 1 minus cos A over sine A. Then the cos A remains there. Down here, the common denominator is cos A. And so we have cos A minus sine A. Oh yeah, just like that. Minus sine A. Then plus, again, sine A is there on top. And then we have sine A down. And then we have sine A minus cos A. If we reciprocate there, we'll have cos squared A over cos A minus sine A plus, again we'll have sine squared A over sine A minus cos A. So then we get some common denominator here. So we'll have cos A minus sine A, and we also have sine A minus cos A. Okay, so these are different. So this way will make it a bit complicated. We want to get sine A plus cos A. So what's the best way of going about this? From the right hand side, from this one here, we factor out the negative so that we remain with so that we make the denominator be what we want. Be the same, I mean this. So here we'll put a minus and take sine squared A over, then switch the denominator to cos A minus sine A. Yeah, then get the denominator now, and then divide by, so we're saying cos A minus sine A in itself, you get 1, so you have cos squared A minus sine squared A. But this is the same as what? The top one there is the difference of two squares, so it is cos A minus sine A, and then cos A plus sine A over cos A minus sine A. So something is cancelling here. This section and this one is cancelling. And so we're remaining with cos A plus sine A. And this is what we have as the right hand side. That's a plus there. So starting with sine and starting with cos, it's the same thing because we are adding. Hence proved.
Sir.
Hello.
I had a very difficult time solving this question. I thought it had an error.
Yeah. So the secret is on when you pull out this negative. If you don't, then you can put up your hand in the test.
Oh, and sometimes you can also apply the difference of two squares.
Yes, because it is applied here.
Okay.
Mhm.
Okay.
Okay, so we go to C. C, solve each trigonometric equation for x, where x lies between 0 and 2 pi. The first one is 2 cos squared x minus 3 sine x plus 3 is equal to 0. Immediately you see sine not squared, cos squared, and it's an equation. You change the squared cos to sine so that you leave the signs alone. And then you expand. So you have 2 minus 2 sine squared x minus 3 sine x plus 3 is equal to 0. So 2 and that 3 there, we are getting 5, 0. So negative 2 and 5 there give us negative 10. So two numbers that when you add, you get negative 3, and when you multiply, you get negative 10. Those are obvious numbers. So you're going to get plus 2 and minus 5, and then plus 5. It's a quadratic. So you factor out, the first one here is 2. So you factor out negative 2 sine x. So it will remain in sine x minus 1. And you factor out 5, so it will remain with that minus 1. You factor out negative 5 there, and then you have sine x minus 1, and then negative 2 sine x minus 5. That is 0. So you are saying sine x is 1. If not so, then sine x should be negative 5 over 2. But negative 5 over 2, this is negative 2.5. But we know that sine runs from negative 1 to 1. Even if you have to sketch it here, it will be 1, negative 1. It goes there, it comes down. It goes up, just like that. It will never reach negative 2.5. So you discard this immediately and remain with the sine x is equal to 1. And it is 1, you can see. It's 1 at 90. Okay, so x is 90. Why else is it 1? To be 1 after the circle. But we just thought we should find x between 0 and 2 pi. So that's the only x that we have there. The second one is cos 2x minus sine x is equal to 0. Now cos 2x has the identity. The easiest identity is cos squared x minus sine squared x. Then that is 0. So because we have a combination of cos squared and sine which is not squared, we'll have to change cos squared to 1 minus sine squared. And then have 1 minus 2 sine squared x minus sine x is 0. So that we remain with minus 2 sine squared x minus sine x plus 1 is 0. The product is negative 2. The sum is negative 1. Which two numbers can do that? Of course, negative 2 will be one of them, and it will be joined by the positive 1. So we factor out negative 2 sine x and remain with sine x plus 1. Factor out 1 and have sine x plus 1. So sine x plus 1 is common. Factor it out. And we remain with negative 2 sine x plus 1. But this is just telling us that sine x is negative 1. If not, then sine x is 1 over 2. Now for negative 1, you can see from the sketch we only have one number, that is 3 pi over 2, which is 270 from the graph. So x here is 3 pi over 2. Where we have issues is on the half. Because as you can see,
So shouldn't that sine x, the one which is half, shouldn't it be negative half?
because the one will go the other side as a negative, then the negative 2 will go to divide, so the negatives will cancel.
Okay,
Yes.
thank you.
Now for the half, you are seeing that half is here. So we have the graph there giving us half. We have another piece of it here giving us half. The question would, since half is positive, sine, you said sine is positive in each quadrant. Remember, sine is positive in the first and second quadrant. So we need to find the angle that gives us half in the first quadrant, and that will be 30, which is pi over 6. We also have to find the angle which gives us half in the second quadrant, and that will be pi, which is 180, minus pi over 6, where we use it as a reference angle. So 6 will be the common denominator. So we'll have 6 pi minus pi, giving us 5 pi over 6. This must be 150. So we have these three values of x as our solutions. So whenever you find a positive, in this case you've seen positive half. If it was negative half, you need to check for sign that gives an angle that gives you half, negative half, meaning an angle in the third quadrant and an angle in the fourth quadrant, or obtained using the reference angle that gives half in the first quadrant. All angles should be written in the given interval. The interval given is this. So this is telling us that we should write our angles in radians. If it was given in this form, then you write your angles in degrees. And you should stop forgetting, because we did this in the past paper where the angles were asked to come in degree form and we gave them as degrees. So today they have come as radians. So give them as radians.